Welcome back, ladies and gentlemen. Today we're going to be taking a look at a very, very important section called factoring using synthetic division, okay? Which is scary because there's a lot going on here, but let's jump in here and take a look. It's only a whopping 2 questions with a warm-up, so we should be okay, all right? So our essential question today is, how do you factor polynomials? And the thing is, we've talked about in class, factoring. If you have a trinomial, you do the x thing, a times c on top, b on the bottom. If you have 4 terms, you do factor by grouping. Well, what we're going to find out today is how do we factor things that have a higher degree, okay, like x to the third, x squared, so on and so forth. This has 4 terms. If you would try to factor by grouping here, you would find you could not do it because it wouldn't match up. But let's see what this says. What are the zeros of this function? The zeros are where your graph hits the x-axis. Okay, so we have a lovely graph over here. So the zeros are pretty simple. Okay, for my first one here, it's the x value that hits the x-axis. So my 0 is -3. Here it would be -1.5. Sorry if it's really tiny to see there. And then this would be -1. Okay, well, that's great. Those are the zeros. Like, that's when it says x equals -3, x equals -1.5, x equals -1. What are the factors? In order to write as a factor, you want to write as a binomial. So to do that, you want to make all of these equal to 0. So how we do that is we add over the 3, and you're going to get x plus 3. Okay. If I add over, let me see if this makes sense. I'm going to do this over the side here. I can rewrite -1.5 as -3 halves. Okay, I think we're all cool with that. You don't want to have fractions in your binomial. So what we can do is, if you multiply both sides by -2, by 2, I'm going to get 2x equals -3, and then if I add the 3 over, 2x equals 2x plus 3 equals 0. So that's how we write out this binomial, all right? You wouldn't want to write it like this is what I'm trying to tell you guys, x plus 1.5, all right? You don't want decimals and you don't want fractions in your binomial, so get in that habit early on. You guys are good enough that you can rewrite 1.5 as a fraction. You're good. And lastly, when I have x equals -1, if I add the 1 over, I'm going to get x plus 1. Okay? So this is going to be the hardest thing for today. These are your zeros. X equals -3, x equals -1.5 or -3 halves, and x equals -1. And when you write as a factor, you want to write as a binomial. Okay? So down here, we're going to factor this. Okay? So here's the interesting thing. When it says f of -3 equals 0, they are telling you, all right, by the factor theorem, a polynomial f of x has a factor x minus k if and only if, that's what IFF stands for. I'll write that down for you. If and only if f of k equals 0. Well, they're telling you here that my k is -3. Okay? All right, so we're going to use what we call synthetic division, which we've done before, all right? Because we want to break this down. I can't do anything with an x cubed right away, but I can do stuff with x squared. So check this out. We're going to put a -3 out here, and I'm going to go ahead and do synthetic division. 2, 11, 18, 9. Now, I want my remainder to be a 0. If it's a 0, I know I'm okay. So here we go, 2, multiply, add them going down, that's 5, multiply, add them going down, multiply. Okay, what we've just done there is, see if you guys can follow me, having an answer of x equals -3, right? The binomial for that is x plus 3, right? Okay, it's just rewriting it. Now this, you started with x cubed, this now becomes an 2x squared plus 5x plus 3. Well, here's the good news. I can factor this, and if I can't factor it, I can use quadratic formula, okay? So over here, I'm going to go ahead and try to factor this. X plus 3 is already good, but if I do a times c on top and b down low, 2 times 3 is 6, 5 down low. What numbers multiply to give you 6 but add to 5? 2 and 3. All right, I'm going to do my work over here. 2x squared and then plus 3. In the middle, I'm going to put plus 2x plus 3x. Okay, boom, 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 boom. Yes, this is not going anywhere. I'm really sorry, but like I said, this is kind of the rest of the entire year. Okay, the x plus 1s are the same. 2x plus 3. All right, very cool. So this x plus 3 hangs out front. That's a 3. I'm so sorry, my handwriting's terrible. And then when I factor this, I'm going to get x plus 1, 2x plus 3. Okay, so there is my complete factored form. Now, quick recap before I move on to the back. What did we do here? Well, we knew one of the answers was -3. So we synthetically divided by -3. That was the x value. That was the 0 for this particular function. When you synthetically divide, I'm breaking it down. It was x cubed, so after I divide it, this becomes an x squared. I need that remainder to be a 0 according to my factor theorem. So this became my new trinomial. We factored this, and that gave us all 3 of our binomials. Okay, or sorry. So we now have all of our factors. Now, if you guys haven't realized that the warm-up was basically this problem, this is fully factored. Okay, these are more difficult problems, obviously. All right, this is a new addition to our toolbox that we've learned so far this year. Okay, so. Very good. Let's flip to the back. We're going to try one more. All right, we're going to get lots of practice with this if we need it. So here we have 1, 0 of f of x equals x cubed minus 2x squared minus 9x plus 18 is x equals 2. Find the other zeros of the function. Okay, that's important. I'm going to get back to that in a second. So we got the whole page here. I love when I have a full page for math problem. It's really exciting. Okay, so I'm going to put the 2 out here. I'm going to go ahead and do synthetic division. 1, -2, -9, 18. I'm just using the coefficients up here, okay? Bring the 1 down, multiply. Ooh, 0. 2 times 0 is 0. -9, if I add them, multiply -18. Uh-oh. Well, let's take a look at this. My answer here is x equals 2. But if I write that as a binomial, it's x minus 2. All right? Cool. Now, it was x cubed. Now it's 1x squared plus 0x minus 9. Do I have to write the 0x there? No. All right. In fact, it's just x squared minus 9. Now, I know I try to I hint a lot at different things and so on and so forth. And here's a quick story for you guys. Lately, I've been tutoring a brilliant student with SAT practice. All right, and as we're going through the SAT book, we've noticed time and time again, they keep bringing back up this. This is something very special. I know I drop it a lot in class, but I just wanted to mention it again. This is a difference of squares problem, okay? Because I have an x squared, something squared, minus 9, which is something squared. So, I can break that up to be x plus 3, x minus 3. All I did was square root x squared, which is x and x, and square root 9, 3 and -3. Now, here's the interesting thing. This is what I want to take a minute to explain. This is what we call fully factored form. All right? When everything is written as a binomial, product of binomials, you are fully factored. What did the directions ask us for? Find the other zeros of the function. So if they ask you to find zeros, okay, I'm then going to do x minus 2 equals 0, x plus 3 equals 0, and x minus 3 equals 0, okay? If finding zeros, okay? So now I solve for this, x equals 2, x equals -3, and then x equals positive 3. And I didn't really show the work there, but I think you guys were cool with adding 2 over, subtracting 3, and adding 3. Now, for those of you that like to see how all the things like inner workings, kind of go together, here's a really fun little thing for you, because it's kind of cool because you guys get to use a graphing calculator. If I go to y equals and I type in my original problem, x to the third minus 2x squared minus 9x plus 18. Now, before I hit graph here, what do you think's going to happen? Well, I'm going to have a graph. It's x to the third's cubic. So I don't know if you guys remember, but we talked about like a positive out front with an odd degree. So it's going to start low, go high. But you see how I found these 3 zeros? 2, -3, 3? Something cool happens here. Maybe you don't see it at first. Here, there it starts low, goes high. But if I zoom in, it's hitting at -3, +2, +3. Why is that important? Because it's right there. Those are your zeros, okay? So everything's working together to give us these answers, all right? Which is pretty interesting. I don't know if you can see the big picture, like, you know, you're good. And again, those of you thinking about pre-calc, honors pre-calc next year, literally they're studying right now for this on their midterm / tests, okay? So keep up the good work, as always. Once you're done with this, ask any questions if you need to, but as always, good luck. We're all counting on you.